Good day, students. Welcome to Mathgotserved.com. And this clip, we're going to be going over section 4.5 of our virtual geometry text on triangle properties. We're going to be looking at how to determine if given sides satisfy the triangle inequality. An example of a problem we're going to be working on today is presented here. What range could the measure of side AC be given the measures of side AB and CB? Don't forget, we have 4 practice problems at the end of this presentation that we'd like you to try out in order to demonstrate mastery of the contents of this presentation. To gain access to our Geometry, Algebra 1, 2, Pre-Calc, and Calculus courses, take a look at a link in the description below, or just visit our website at Mathgotserved.com. To get us started, let's take a look at the theorem that will be guiding our problem solving process. So this is our website, mathgotserved.com/geometry. So we're going to scroll down to our theorems and postulates collection. So here we have geometry theorems and postulates. Number 4 under triangles is what we're going to be looking at, okay? Now, if you notice, there are 2 parts of the triangle inequality theorem. We're going to be using both of them in the examples we're working on today, okay? The first one basically states that the sum of any 2 sides of a triangle is greater than the third side. So consider this triangle right here with sides A, B, C. So if I add any 2 sides like AB, it's going to be bigger than the third side C. A plus C is going to be bigger than B, and B plus C is going to be bigger than A, okay? And the second part relates to the connection between a side and the other two. Any side is between the measures of the sum and the difference of the other 2 sides, okay? So for example, consider side C. This side right here is going to be greater than the difference of these 2 sides and less than the sum. Same with B and A, okay? So these are the triangle inequality theorems that we're going to be using for the examples for today. To gain access to these theorems and more, just visit our website at mathgotserved.com/geometry and you can gain access to it. All right, so the instructions for numbers 1 and 2, what we're going to do is we're going to be given 3 sides and we're to 3 measures, and we're to determine if those measures can be measures of the sides of a triangle. In other words, do the measures satisfy the conditions for the triangle inequality? So number 1, let's say we have 7, 7, and 11. Let's test this out. So for this one, we're just going to label the sides. A, B, C, doesn't really matter the order that you label them, but I'm just going to follow the alphabetical order, A, B, C. And then we're going to carry out 3 tests, okay? The 3 tests for the triangle inequality. In order for the measures to be the size of the triangle, note, all 3 tests must be passed, okay? The test must pass, the sides must pass all 3 tests. So what are the tests that I'm talking about? So the first one is A plus C has to be greater than, let's do AB first. A plus B has to be greater than C. The second test is that A plus C has to be greater than B. And then the third test is that B plus C has to be greater than A. All right, I just paired all the sides together, and the sum of any 2 sides has to be bigger than the third side. Okay, so let's go ahead and test it out. So the first one, so A is 7, B is 7, C is 11. So question, is 7 plus 7 greater than 11? 7 plus 7 is 14, and that's greater than 11. Check, it passes the first test. Move on to the next one. A plus C, 7 plus 11, is it greater than the third side? Than the third side, which is B in this case, 7. Is 7 plus 11 bigger than 7? 7 plus 11 is 18, and it's definitely bigger than 7. Check. Keep on going, okay? All right, last one. We have to test all 3 conditions. So the last one is B plus C, which is 7 plus 11. Is it greater than 7? We've already done something like this, right? Because A and B are the same. 7 plus 11 is 18, and it's definitely greater than 7, so that's a pass. So since these sides pass the 3 tests, our conclusion is that 7, 7, and 11 can be measures of sides of a triangle. Okay, so that's basically how the triangle inequality works. Let's go ahead and try out another example, problem number 2. All right, so for question number 2, let's say we are given three numbers, or number 2. Let's say we have 5, 3, and 10. Okay, so we're going to carry out the test again to see if it passes the 3 tests for the triangle inequality. 1, 2, 3. So A, B, C. Let's call the side measures A, B, C. So the tests are A plus B has to be bigger than C. A plus C has to be bigger than B. And do you know what the last one is? B plus C has to be bigger than A. Okay? All right, so let's start with the first test. A plus B is 5 plus 3. Is 5 plus 3 bigger than 10? 5 plus 3 is 8. And 8 is smaller than 10? Absolutely not. So this is a fail right here. Okay? If you try and create a triangle with these measures, what's going to happen is that the two sides, 5 and 3, will collapse because they're not long enough to touch each other because 10 is too long. Alrighty? If one of these tests fail, it's an automatic fail. So there's no need to test 2 and 3. So I will just go right to the conclusion. 5, 3, 10 cannot be measures of the sides of a triangle. Okay? All right, let's move on to question number 3. All right, so number 3, the instructions are given the two sides of a triangle. Find the range of values for the third side. Okay? So what reasonable collection of values can ensure that the third side will enable you to create a triangle given the first two sides? So for number 3, let's say we have the two sides are 12 and 6. So what is the range of values for the third side to ensure that you can create a triangle? So we're going to use the second part of our triangle inequality theorem. Okay, so third one is a question mark. Let's label them A, B, C. Doesn't really matter the order. So A, B, C. So what range for C? So we need to find the range for C. So find range for C. So according to the theorem, what do we know? According to the theorem, C basically is between the sum and the difference of the other two sides. Righty? So A minus B is less than C, and C is less than A plus B. All right, and then oh snap, we need to put in an absolute value here because we just care about the magnitude of the difference. So this could be a negative. All right, so let's do it. So if we substitute our values in here, A minus B in this case, 12 minus 6, the difference between the sides, okay, is the lower bound for C, and then C has to be less than the sum of the two sides in order for you to be able to create a triangle. So let's put an absolute value here because we don't want it to be negative. So 12 minus 6, the absolute value of that is 6. So 6 is less than C, and C is less than 12 plus 6, 18. Okay, so what does this mean? Let's write down a statement for this. It basically means that the third side must be between what? What values? Must be between the values of 6 and 18 to form a triangle. Okay? So there you have it. So number 4, we have a visual representation. We are given a triangle and we are to determine the range of measures for side AC. Okay, so here we have 12 and here we have 17. Oh, sorry, that's not that side right there. This is given. So this is side AB, is side BC is 17. All right, so this is a side. What range of measures for side AC we'll ensure that we have a triangle. Okay. All right. So we're going to use the second part 2 of our triangle inequality theorem to figure this one out too. So let's call this side little a, let's call this side little b, and let's call this side little c. So in this case, we are going to find the range for AC, which is the same thing as B. Okay, so if you revisit the theorems that the theorem for triangle inequality that we showed earlier, number 2, there are 3 variations there. So if you look at, I think the second one, you see that, so for B has to be between the sum of AC and the absolute value of A minus C. So the theorem is going to be A minus C, absolute value of that, because we don't want negative answers, is less than B, and B has to be smaller than the sum of the other two sides. So any side is between the sum and the difference of the other two sides. So this is the condition that we have right here. So in order to determine the range for B, we're just going to substitute our C and A values into this inequality and solve it. Alrighty, so we have the absolute value of A minus C, which is 17 minus 12. That has to be smaller than B, and that has to be smaller than 17 plus 12. Alright, absolute value of 17 minus 12, 17 minus 12 is 5, so 5 is less than B, and B is less than 29. Okay, so let's go ahead and write a conclusion. The range of values, the range of measures for AC is between what and what? Is between 5 and 29. So any value between 5 and 29 will enable you to create a triangle using 12 and 17 as a measure of the other two sides. All right, it's now your turn. You have 4 practice problems to work on in order to demonstrate to us that you've mastered the contents of this tutorial. So go ahead and pause this video at this time. Try these 4 problems. When you're done, click on the playback button, and we're going to reveal to you what the correct answers are. Welcome back. Hopefully you had a chance to try out the practice problems. Let's take a look at what the solutions are. For number 1, do these 3 sides satisfy could they be measures of the sides of a triangle? The answer is no. Okay. All right. Number 2, how about these 3 sides? The answer is no for these. Number 3, what range? When for the third side, given 9 and 10, as 2 sides, 1 is less than C and C is less than, depending on how you labeled it, okay, is less than 19. So the third side is what? The third side is between 1 and 19. How about number 4? What are the range measures for AB? Well, that is going to be between, so if we call this little c, is going to be between the difference, which is 9, and the sum, which is 19. No, sorry, the difference is not 9. The difference, yeah, hold on. Difference is 9, between 9 and 19. All right, if you want to write a statement for that, we're simply going to say AB measures between what? Between 9 and 19. So that's the range that we have. Alrighty. So ladies and gentlemen, how well did you do in these 4 practice problems? Well, let us know in the comment section below how well you did. If there are any questions that you have or clarifications you need, either from these practice problems or what we covered in the tutorial, let us know. We'll be more than glad to support you. Thanks so much for taking the time to support this, to watch this presentation. To help support our channel, please give us a thumbs up. You can share, and do not forget to subscribe. To gain access to tons of support resources like we showed to you earlier, you can just visit our website at mathgotserved.com. And if you have any questions, comments, or special requests, just place it in the comment section below, and we'll be more than glad to support you. Thanks again for watching, and have a wonderful day. Goodbye.